So for today's webinar, we are going to have a consumer product. And today we'll just jump right in to what part that is. And it is a consumer product. This is a 3D scan that was captured of a mold for a plastic chair. And we'll go over the process of reverse engineering this mold for a plastic chair and show how we're able to create a model from that. So you can see here on the left-hand side, you have designs that are created, engineering designs, and then they create the model, and then from there, this is a legacy mold design that they would like to capture the mold and then redesign the part and create a new mold of it. So you see here, in this instance, we don't actually have a part in our hand that we're 3D scanning. This is an example of taking the tooling that created the part to then scan and model the tooling to create the part from there. So you see this is an interesting application where we're scanning that tooling mold to reverse engineer the legacy mold design. And if you think about it, there's a lot of designs out there. You know, the mold design world is just absolutely massive. And how many legacy designs there are out there where maybe the parts don't even exist anymore, but we do have the molds, and being able to capture that information with 3D scan data, reverse engineer the mold design to then back into getting the part design, and then making whatever modifications you might need to make to then remanufacture the mold. Or this could even be, that would be the last mold in existence for this part, and you need to make backup molds to have them on hand to be able to pull parts. With that, let's go ahead and jump over to our slide of 3D scanners just to talk about the different devices that are used to capture this type of information. So for this specific application, there's a whole host of devices that you would be able to use. Most of the time, you would probably end up using one that you could bring the scanner to the part in this instance, because these mold designs sometimes are very big and bulky. So you could use something along the lines of a portable CMM like this arm right here, or this arm right here, where you bring it out to the workpiece and scan it that way. You could use that. There are examples of being able to use white light scanners on a tripod and bringing those over to the part and scanning that way. And then, of course, you also have the option of using handheld scanners, which handheld scanners are known for being the most portable devices on the market. So you can bring a handheld scanner out to the part and scan it as well. I believe this one was captured with ARM information, like portable CMM like this one today. So with that, let's jump over to the reverse engineering process. As usual, we start out with this first slide that's just talking a little bit about Design X and what this product does. And I just try to give the summary in slightly different ways for people that have heard this over and over again. I'm sorry, but I just want to make sure that everybody understands what this product is and what its intended use is. So as I always propose this, over the many years, 30 plus years, devices similar to one screenshotted here on the left-hand side came about on the market, capturing 3D measurement data. And many of them capture high resolution and in some cases high accuracy data, 3D point cloud information or polygon information that is very high density. And when those devices came about in the market, immediately engineers and designers and people within quality departments saw the possibilities there that these devices could be used to capture the shapes of parts and bring them into 3D softwares to either make comparisons and measurements or reverse engineer the shapes of parts. There became quickly people noticed that that data was too dense and of a different nature than most of the 3D CAD softwares that existed in the market. So specialized softwares cropped up to deal with that. And Design X is our solution where we take these high resolution, very high density scan data sets, and we allow you to work with them in a native environment and recreate CAD models or other deliverables from that data for use primarily in manufacturing, but not only limited to manufacturing, and lots of other markets, as you see on the right-hand side, whether it's CAD, CNC softwares, and just going straight to manufacturing. And as you can see, the additive market where printing and those types of deliverables are also captured. So Design X, its specialty is taking that scan data not as a second class citizen into the CAD world, being able to extract whatever it is that you need out of that information to then send downstream in your manufacturing workflow. And our webinar weekly focuses on different applications similar to this one that's shown right here, where these impellers are reverse engineered to recreate these highly organic shapes into CAD models, is highlighting different applications similar to these that are success stories for Design X. And along the way, I give tech information or tech tips for current users of the software. So this has multiple layers to it where we talk about successful applications where we've utilized the software, and we try to sharpen everybody's skills by highlighting specific applications that are very interesting. So before we jump into our applications in our presentation today, as usual, I wanted to go over our Geomagic Design X product tiers, just to make sure everyone is aware that today I'm using Geomagic Design X Pro, but we also have two other products within this product family. So we have the ability to sell Geomagic Design X Go, Geomagic Design X Plus, and Pro. So I just wanted to make sure that everybody is aware of those. I like to say that Go is designed around extraction. It doesn't have plugins, and it's designed around extraction of primitive shapes, sketches, and all of those things. You can do advanced modeling in there, but I would say it's good at extracting and sending that stuff over to CAD. And remember, it doesn't have plugins built in. It will import scan data from almost every source imaginable. And then Plus is those same import tools, but we also have the plugins built in. And outside of that, we also have more modeling tools. So it's the basic modeling tools as opposed to Design X Go. I like to say it's more about extraction and sending over to CAD. This one you can do basic modeling or also send it to CAD, as all three of these have live transfer built in. And then of course Pro, the one that we've talked about extensively on this webinar series. And we do have subscription options available for all three tiers. So with that, we'll go ahead and jump into today's content. So here is the model. You see, today we're dealing with a sheet metal part where we are designing this as a zero thickness surface, and then we are going to, and the reason why is because many times with this type of part, you bring this over to special mold making section of CAD, whether it is your version of CAD that has a mold making software, or a separate mold making software altogether. There are different products out there that have been designed to do CAD modeling tasks on mold making applications specifically. So basically, what I'm saying is they're just like CAD products out there that are designed specifically only for the mold making world. An example of one is one that we used to have as a department of a company that we were at previously is Cimatron. If you've ever heard of Cimatron, that is a standalone CAD software that's designed with the sole purpose of creating mold designs, and they have lots of really cool tools to help you design all kinds of inserts and injection ports and all kinds of stuff. I am obviously not from that market, or I could speak a little more intelligently about it, but there are all kinds of things that in generic CAD would take a lot longer to do, and they have all these different mold blocks designed ahead of time and all kinds of different tools associated with it. So in this instance, what we're doing is we're designing the geometry that we need to then drop into one of those mold making softwares, right? That will then take this, and then you can just Boolean this or cut this away from a mold block and do the necessary things over there to then create your mold from there on out. So just go ahead and look, and you see here that this is the way this mold is designed, where it is in this vertical nature. So I would imagine there is a mold block of this sort right here from this top down. So this is the final deliverable here, but we will go ahead and turn that off, and we will roll all the way back. And you will see right out of the gate here, roll forward one more time. We went ahead and we brought in the scan data right here. So this is the scan of the mold there, and you just look in and see that we have that edge. And you'll notice we have one other thing here too. We have we'll just go ahead and hide the mesh here. We have an imported legacy design of some sort that was given to us as a reference as well. Now, I think this is because this design is completely different, and that comes from the mold block that they want to utilize. So you'll notice that right out of the gate, if I just skip forward a little bit and we turn the mesh off, that we're basically going to use that rim area of that design to make sure that we designed it in with the rest of the, so I'll just turn this on real quick and just show that and hide the surface. And make sure that we use that as a guide to help us design the piece here. So that's what I think that's for. This isn't my project, so I'm inferring this, but this is being used to give us a guide as to the edge of the part from another design, right? Which is very easily done here. So now let's go ahead and jump in. We will, first of all, we're going to do a couple mesh fits, and I'll just turn off the imported geometry. So we went ahead and you see that they did mesh fits on the scan data there. So I'll just pop that on, and you'll see if I just double click that, you can even edit the mesh fit. I don't know if I've brought that up in our webinar before, that you can see the data that was used to extract that mesh fit, and you can even make updates and changes to it. So if you wanted this to be if you wanted to smooth that out a little more, you could adjust the smooth slider. You can adjust how far it extends, the type of extension method. You can even adjust the number of control points used to create that surface. All of that you can adjust after the fact. You can see that we can go ahead and bring that in. I just wanted to look at this one real quick. All right, there we go. So then after we fit those two mesh fits, we go ahead and we trim those two together. And then you see here, they're going to create a separate type of blend. So rather than put a fillet on that edge, you see what they're going to do is, here just a minute, we'll turn that other one off. You can create a fillet manually, or you could create a lofted blend between those if you're trying to follow the geometry closer or looser. It just depends on what you're trying to do. If you need that to be a constant radius, go ahead and do that. If not, then you can do that as a separate entity, as a fillet or as a surface blend. So we'll go ahead and we'll turn the mesh off real quick. I just wanted to look. Okay, yes. So that bottom piece, we're going ahead and we're fitting that. Extend, extend. Turn it off so we can see what we're dealing with. And then we'll trim that together. And then I'll turn that new piece on there. Let's see what they do here. Yep, so this is that same technique here where you create a 3D sketch. We use these guys for trimming purposes. Roll forward. We do a surface offset. And in this instance, the surface offset is it's just being used as a duplicate surface. So you'll see here, I can tell right away what they're doing there is sometimes when you use a surface to trim with another one, it'll get rid of that surface. So sometimes you'll use a surface offset 0 to then duplicate a surface. So that way when you go ahead and you trim it to another one, you still have the tool entity available to use for other purposes later. So that's a neat little Design X specific trick, just based on the way that we work in here. But other CAD packages have different ways of doing that. So if I go ahead and roll forward, it looks like we extend the surfaces here. Let me just double click on that. If there's ever any confusion, again, you can double click and see, hey, we're extending that surface in 3 directions there. And then I can just escape out of that and not make any changes. So now we'll go ahead and roll forward and trim. All right, let me just pause and turn some of this on and off. And we'll just hide these surfaces real quick. And then turn it back on, just to get an idea of what we're dealing with here. And then we're doing a split face. So they created a notch there on that. And then lofted between those two. So let's go ahead and do a little bit of cleanup here. So we'll just hide some surfaces. Keep that one on, keep that one on. Loft, loft. Okay. So you see what's going on here is they took that blended surface and they created a split face using this. So they just drew a square out of the middle, and they used it to split the faces and then create lofts on each side. We extended, trimmed it back to that same exact sketch, sew it all together, and then do a fill face. And the reason why it was all done that way is that using the lofts and the trimming and everything creates a nice continuous curvature surface there. So it has tangency. And again, we'll do a surface offset 0. Trim, trim, trim. So let's just, they trim those two together, create those bands, trim it back, loft between, and then sew it together. And then they trim that with the other surface. And then do a split face. Just open that up. So you can see they just drew a line breaking that and did a split face between the two. And they're going to probably do that same thing over here as well. And then extend. Trim with that sketch that they drew, and then loft between the sides, the edges. That way we have a nice curvature to that boundary, and then sew it all together to make it all one surface. And then do the same thing on this side. So you see here that they're, oh, never mind. I jumped forward a few steps. It looks like they're going to, let's just jump back here. Looks like we're just going to mirror the thing. So we just did a surface trim with a plane. Yep, just plane one. Just created a plane and deleted it. Trim off to the side here. And we'll just turn the mesh on to see where we're at. Just turn the surface off. It's all because it has that little dip in there. And then you see that they drew a 3D sketch because it looks like they're going to create a blend there. So go ahead and trim that away and then loft between sew and then loft. Now they're doing they're drawing some sketches there and splitting the face so that way they can create a loft that jumps across there. Sew it together and then fill face that last piece. Surface offset 0, so copy and paste it. Now this extend, I didn't see where the extend was, so I'll just double click it. Okay, so now we're working down here. We're going to use that banded edge. There, you see that? We're extending that. Extend that. You see here we did a sketch. Let's just look at that real quick. I'm going to go in the mesh sketch, turn this on, maybe hide the surfaces real quick. And you see that we're defining the edge of that seat by using a 2D sketch. Now, let's keep going. Looks like we're going to work our way around the border. Fill it between those two. Now we're going to do the foot end. Trim those two together and fillet that. And the nice thing about zero thickness surfaces is where that intersects, it's just going to trim when we go ahead and trim it all together. So you see that? We got this edge trim tool that's getting built there. And then you see they drew the two different profiles there, and then fillet, a full face fillet there. And you see here what they used. And this would be something for me to talk about in a future webinar here, where they used those full face fillets, they used those curves, those sketch chains there as guides for the fillet. See that? There we go. Now we're going to trim from this direction. Trim from that top direction. Again, it's all of this is going to form another band of a trim around the border is really where we're going with this. See that? So we're going to trim all these pieces together and work our way around the outside. And you see that we filleted that together. And fillet that. Making one giant wrap around. And we'll just turn the mesh on real quick to see there. So there's something particular there. They went ahead and did a mesh fit to that area. Because it doesn't really break down to like an extrude or a specific. And then, oh, it looks like we fit another one. Oh, we extended it and then trimmed that in with the rest of the pieces there. So let's turn the mesh off. It's very organic in that area, so they just went ahead and draped a surface over that. And again, do the trim loft between it. Trim and sew. To bring all that back together. So now they've jumped on over here. Yeah, let's go ahead and go past the delete face. Let's see where that delete face was. Okay, so they removed those pieces. And then now we went down the middle there and trimmed that together. Applied a fillet, a variable fillet all the way around the edge there. So we went ahead and extruded a surface using that sketch in this direction. And that was all captured from here, right? Apply a fillet to that. And then now trim the whole edge there. And we'll see if this trim is the, yep, trim all those pieces away. Then we applied a fillet there. And then mirror the whole thing. So there's the mirrored piece. So if I were to thicken this, I could come over here and say, hey, I want to thicken surface, 3 millimeters or something. I don't know. Hit OK. And we could create a solid out of that if we wanted to. But the idea here now is that this surface would then be moved over to a mold software, to where you would bring this in and use this to boolean away from a mold block and fit it in, because again, here's the coordinate system. So the block would inevitably be along the lines of this, just to kind of here, let's do that. Let's use this top. And let's do this. Like this. Actually, we have a separate tool in here. Right here. And we'll just minimize this. Come over and grab that. Yeah, okay. There we go. So if I just get out of that sketch there. So then extrude this. You could say up to surface there. Up to this. Or let's just do this. Let's just blind. There we go. And then we'll just do a cut with surface. So this is the idea of what I'm trying to describe here. If I just turn that off, of like the way the tool would be designed. And then from there you would create surfaces coming off in all the different directions to create the rest of the mold block, but this will show the general idea of what the process looks like. So with that, we'll go ahead and jump back over to the PowerPoint. I hope everyone has been enjoying the RE Lab webinar, and I'm always striving to make it better and gather input from a variety of sources. And I had the idea to create a survey and put out a survey just asking for feedback. Mainly the feedback is just to gather uh, data points on the topics, the applications, and if there are any other ideas of applications that people might like us to focus on, and just kind of get the pulse of what you guys like to see, what you like to hear. So this is a very open forum. It asks for some feedback and suggestions, and we'll go through those and implement those. Um, so if you have any proposed topics or things that you might want to learn about Design X, then go ahead and scan this QR code. It takes you straight to a form, and we will take that and implement it. As I stated before, Geomagic Design X Pro is part of a complete lineup of software that has three tiers of Go, Plus, and Pro. And again, the differentiators are that Pro has all the tools built in. Plus has plugins and basic modeling tools. And Go primarily is focused on importing data. It has no plugins built in, but it brings in data from POI, OBJ, STL, all those different import formats. We have a huge library of formats that we bring in, more than almost anybody out in the market, and allows you to extract basic model information, send it over to CAD. So Go, extract basic model information, plus add plugins, add more modeling tools. Pro, you get everything. And you have the ability to upgrade from one to the other by trading in Go, trading in Plus to get Pro. So it's a great ecosystem, a great product lineup. But we wanted to make sure that we point out that Pro is part of this lineup and there are other options available.